Good morning, everybody. I am Prakash, lecturer in chemistry, JPT Nirmal. Subject is chemistry. Today we have discussing about the electrochemistry for first year, second semester students. So, in the previous class, we have to discuss about the batteries, and that batteries are two types: primary batteries and secondary batteries. Primary batteries does not rechargeable batteries. It will be in which that batteries does not take place reverse reactions, reverse electrode reactions. So secondary batteries, which are in which batteries takes place the reverse reactions, reverse electrode reactions, and we have to use it again and again, and rechargeable batteries. So for example, rechargeable batteries, lead storage battery and nickel cadmium batteries. So in the present session, we have to discuss about the lead storage batteries. So lead storage battery is a it is a secondary cell or secondary battery, that is operates as voltaic cell as well as electrical cell. So when operating as a voltaic cell, it supplies the electrical energy, means nothing but discharging, and it operates as a electrical cell during charging. So lead storage battery, in the lead storage battery, a number of plates and lead plates and lead oxide plates are alternatively connected in parallel. The lead plates act as anodes, which are denoted with the negative, and lead oxide plates act as cathodes. All these plates are separated from each other by the insulators like wood or a rubber strips. The entire arrangement is immersed into 20 to 21 percentage of H2SO precipitation. Working of lead storage battery. However, there the construction of lead storage battery. Lead storage battery. It is a secondary cell, that means it operates as a voltaic as well as the electrolytic cell. When operating as a voltaic cell or galvanic cell, it's supply the electrical energy, means nothing but in the discharging process it will be act as a galvanic cell, and it operates as a electrical cell during the charging. When it is chargeable battery, when during the charging it will be act as a electrolytic cell. Lead storage battery In the lead storage battery, a number of PV plates and PbO2 plates are alternatively connected in parallel. The PV plates act as anodes, which are indicated with the negative sign, and PbO2 plates act as cathode, which are indicated with the positive sign. All these plates are separated from each other by insulators like wood or rubber strips. The entire arrangement is immersed in 20 to 21 percentage of H2SO4 solution. Working of lead storage battery discharging. By discharging, however, that work discharging. When the lead storage cell operates as a voltaic cell, following reactions occur. Working of lead storage battery at anode, lead undergoes oxidation to the formation of Pb plus 2, which combines with the SO4 minus 2, and formation of insoluble PbSO4. So Pb gives 2, Pb plus 2 electrons oxidation. Pb plus 2 again it will be react with the SO4 minus 2 gives the PbSO4. Working of lead storage battery. At cathode, however, it is working. PbO2 is reduced to the Pb plus 2, which also combines with the SO4 minus 2 and forms the PbSO4. So the reaction PbO2 plus 4H plus 2 electrons give to Pb plus 2 plus 2H2O reduction. This is the reduction reaction. Overall cell reaction during the discharging is Pb plus Pb O2 plus 2H2SO4 gives to 2PbSO4 plus 2H2O plus energy. So this is a wonderful and super, and however that the strong and the life, its life period also very long, and it is a very good battery. And lead storage battery, however, discussed we are that is the construction like that is there. So this is the parallel series. Parallelly connected the, however there we have to connected the PV plates and PbO2 plates. PV plates connected one side and PbO2 plates connected another side. Whatever it PV plates act as a anodes, PbO2 plates act as a cathodes. Here anode is represented with the negative symbol and cathode represented with the positive symbol. And here we are using the aqueous solution H2SO4 solution. Lead storage battery, it may be noted as a lead sulfate is precipitates at both the electrodes and H2SO4 is usually high. So concentration of H2SO4 decreases. This is totally at the discharging of the energy whenever it act as galvanic cell. The can be in the recharging functioning lead storage battery, they can be charged by the passing electric current. Then reactions are reversible. Wherever the reactions are exist in the discharging, that quite opposite reactions are takes place. However, here where the oxidation is takes place, where the reduction is takes place. So, quite opposite reactions are takes place in the recharging of lead storage battery. So, in the discharging, that battery is act as a voltaic or galvanic cell, but in the recharging of lead storage battery, it will be act as a electrolytic cell. As a result, Pb is formed at the cathode and PbO2 at anode. The concentration of H2SO4 increases. So, recharging of lead storage battery at cathode PbSO4 plus 2 electrons gives to Pb plus SO4 minus 2 reaction. Reduction reaction takes place at cathode. At anode, PbSO4 plus 2H2O gives to PbO2 plus 4H plus SO4 minus 2 plus 2 electrons oxidation. So by these reactions it will be going to be chargeable the battery. Then it will be again and again used as a batteries. So however that uses of the lead storage batteries. The battery commonly used in automobiles is a combination of six lead cells in a series. EMF of this battery is 12 volts. It is used to supply the current in the electrical vehicles, telephone exchanges, railway trains, mines, hospitals, laboratories, etc. So, dear my students, remember once again, lead storage battery it is a secondary cell, that is it operates as a voltaic cell as well as the electrical cell. When operating as a voltaic cell, it supplies electrical energy, means nothing but undergoing discharging it will be act as a galvanic cell or voltaic cell, and it is operates as electrical cell during the charging. So whenever it will be going to be recharging charging, then it will be act as a electrical cell. Lead lead storage battery, in the lead storage battery the number of PV plates and PbO2 plates are alternatively connected in the parallel series. So lead plates act as a anodes, which are we are represented with the negative symbol, and PbO2 lead oxide plates act as a cathode. Here cathode act as a plus. However, In recharging charging process, the PV plates act as a cathodes. PbO2 plates act as a anodes. So all these plates are separated from each other by the insulators like wood and rubber strips. The entire arrangement is immersed in 20 to 21 percentage of H2SO4 solution. Working of lead storage battery. In the discharging, when the lead storage cell operates as a voltage cell, the following reactions occur. So, at anode, lead undergoes oxidation to be formation of Pb plus 2, which combines with the SO4 minus 2 and form insoluble PbSO4. Here Pb gives to Pb plus 2 electrons. This is called as the oxidation takes place at anode. Pb plus 2 is unstable and it will be again combined with the SO4 minus 2 gives to PbSO4. At cathode, PbO2 is reduced to Pb plus 2, which is also combines with the SO4 minus 2 and form the PbSO4, which is exist at the cathode. PbO2 plus 4H plus ions plus 2 electrons gives to Pb plus 2 electrons. Overall cell reaction during the discharge is Pb plus PbO2 plus 2H2SO4 gives to PbSO4 plus 2H2O plus energy. So, lead storage battery, however, looking is here the left side, whatever their anode is there, that anode symbol is negative, and right side taken as a all in the parallel series and connected in the positive cap. Okay, these are the connected with the wire, that is symbol is called as positive, which is called as the cathode and anode, and Pb plates, PbO2 plates, and of course H2SO4 solution, which is act as a electrolytical solution. And lead storage battery, it may be noted that lead sulfate is precipitates at both the electrodes and H2SO4 is used up, so concentration of H2SO4 is decreases. Recharging of lead storage battery, that can be charged by the passing electric current, then reactions are reversed. As a result, the Pb is formed at cathode and PbO2 at anode. The concentration of H2SO4 is increases. By recharging a blood storage battery at cathode, PbSO4 plus 2 electrons gives to Pb plus SO4 minus 2 reduction. This takes place at cathode. At anode, PbSO4 plus 2 H2O gives to PbO2 plus 4H plus ions plus SO4 minus 2 plus 2 electrons. Oxidation takes place at anode. By that, battery will be charged. So, like that batteries we are using in the commonly used in the automobiles is a combination of 6 lead cells in a series electromotive force. This battery is 12 volts. It is used to supply the current in the electrical vehicles, telephone exchanges, railway trains, and mines, hospitals, laboratories, etc. So in further classes we have to discuss about the nickel cadmium storage batteries and oxygen hydrogen gas batteries are we are discussing in the next class. So everybody you should refer the textbooks and read that, and if you have any doubts tomorrow class you have to ask the doubts in the lead storage battery also, and you have to read the nickel cadmium battery and oxygen hydrogen gas batteries. However, we have to study about the in this session lead storage battery same as like that, the nickel and cadmium battery also same as like that. We have to take in that, and that one also secondary battery, that one also discharging and recharging is there, and that one batteries also we are used again, and it's a precious, we have to make with a precious metal and it will be used to, and its cost also very high, and that batteries used to we are hearing devices, the smallest devices we are using that batteries like that batteries. So thank you everybody. We will meet in the next session.